Welcome to Easy BTech, your guide for BTech and beyond. In this channel, you can learn the subject very easily. Today, we are going to discuss the subject topic is serial access memories. My name is G. Sampath. I'm going to explain the subject VLSI design. So let us see. So far, we are discussing the memories, DRAM, SRAM. Then the another memory storage is serial access memories, right? Serial access memories. Serial access memories. Serial access memories. So by using the serial access memories, data storage in the form of digital, right? Stored data by using serial access memories, stored data, stored data in the digital form, stored data in digital form, right? Digital form, stored data in digital form, which can also hold the data and address, which can also hold the data, hold the data, hold the data and address. Hold the data and address using this, using using in ROM, read-only memory, ROM, and a flash memory. Okay, flash memory. So it is a permanent storage data. If the power will be off, data will not arise. Okay, so flash memory also used in CPU, right? These are the applications and definition of a serial access memory. So stored data in digital form, which can also hold data and address using in read-only memory. It is also in flash memory, also used in CPU. So data is different types of serial access memories, right? Serial access memories types. Serial access memories types. Let us see the different types of serial access memories, right? Okay, so what are those? Let us see this one. The first one is serial in. The data is serial in, serial out, serial in, serial out, right? We call it is serial in, serial out, CISO, right? The second one is serial in, parallel out, serial in, parallel out. The second one, this is serial in, parallel out. Second type of data is the digital form. It is send input as a serial and output is also serial data and parallel output data. And the third one we can say parallel in, parallel in, serial out, parallel in, serial out ma. Okay, parallel in, serial out, that is the third one. Parallel data in, we get the serial output data. The fourth one is parallel in, parallel out, parallel in, parallel out, right? Parallel in, parallel out. We call it is parallel in, parallel out. So this may be asked in the external examination. Explain the serial access memories. Anyone will be asked serial in, serial out, or directly it will ask you the types. You can explain this, right? Let us see the block diagram of block diagrams. Block diagram of serial access memories. Diagram of serial access memories. Serial access memories. Okay, block diagram of serial access memories. Let us see the block diagrams here. The first one is what is the first one? Serial in, serial out. You can see we are applying serial in, serial out. Let us take the 4 data. We are applying serial, taking output serial. Okay, so data in, this is data in. Okay, data in and data out. Data in, data out. Right, let us take this one is the D0, D1, D2, D3. So data is through the flip-flops. Data through the flip-flops. Flip-flops which hold and store. So temporary hold and store. Hold and store the data. Right? Hold and store the data. Flip-flops. So it is serial access memories. It will be flash memory. ROM means it's permanent. Even the power will be off. It will be stored permanently. Right? It will be stored permanently. The second one is serial in, serial in, parallel out. Right, the flip-flops are here. So 4 flip-flops means it process the 4-bit data out. Right, we are applying input over here, taking the output parallelly. Right, so this is data in and data out parallel. Data out parallel. Parallel. You can say this is so serial in, serial out. Serial in, serial out. Flip-flops D0, D1, D2 and D3 more. D1 and D2, D3. So this is serial in, parallel out. Serial in, parallel out. So black diagram. And the third one is parallel in, serial out. Parallel in, serial out. Let me see this one. Yeah, let me see this one. 4 input data, 4 parallel input data. Okay. Let we are applying 4 parallel input data and output is serial we can take. Okay. So parallel input data, parallel input data, parallel input data and serial out. Okay, serial out. Parallel input data, serial out. Let's take D0, D1, D2 data processing to the flip flop, right? D3. So parallel in, parallel out. So this is we call it is parallel in, serial out, right? Parallel in, serial out. And the fourth one is we are applying parallel input data. We can take the parallel output data, right? Parallel input data, parallel output data. So parallel input data and parallel output data, right? Let me take these arrows. So it is output data. So this is input data, output data, input data, where you are applying the data input parallel. So you can say it is parallel input data, parallel input data, parallel output data. So this is parallel input data, digital data processing through the flip-flops D0, D1, D2 and D3. Output data is also parallel output data, parallel output data. right? This is about the four types of block diagrams of serial in, serial out, serial in, parallel in, serial out, and parallel in, parallel out, right? These are the four types of serial access memories, right? Let us see the circuit representation. The first one is the circuit representation, serial in, serial out. So in the external examination, some of you just finished with the block diagram. You just also explain the circuit diagram, then you will get good marks, ma. Okay, the circuit diagram means by using flip-flops. If you explain this with the flip-flop, it will be good, right? So you can see the flip-flops over here. Used here D flip-flop. Used here D flip-flop, ma. Okay, you can see this one. Let us take the four input data, right? Four input data we are applying. Okay, four blocks are four flip-flops. So we are applying data in. Okay, data in, digital data in, like it is a D naught. Output is Q naught. So this is second flip-flop. Okay, D1. This is D1, Q1, right? D2, Q2, D3, and Q3, right? The data is serially we are applying, then data output is also serial. Data output, right? Every time we apply a clock signal, so each clock pulse is applied. Okay, the first clock pulse is applied, the data will be shifted, right? The clock pulse is applied to the all the flip-flops, right? The clock pulse is applied. So this is a clock signal. The clock signal is applied. Every time the clock signal is applied, the data process serially, right? For example, let us see the table over here. If you are applying a clock, okay, clock, and data in. So data processing outputs are Q naught, Q1, Q2, and Q3 more. So when clock is low, for example, so this is an example when you see actually the data is applied, right? What happens? You can see this one. Well, the clock signal is applied over here. Okay. When clock is low, when clock is low, data is equal to 1. So there is no data shifting. Okay, 0, 0, 0 initially. All the outputs are here, 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 and here. Output should be 0. When clock is high, first clock pulse is applied. First clock pulse is applied, data is equal to 1. Then data will goes to this D flip-flop. Then output also 1, same. So the truth table of D flip-flop, whatever the input, output also same. So D flip-flop output Qn plus 1. The next state, if 0 is the input, output is also 0. 0 is 1, input is 1, output is also 1. It will be same output data. So that is a memory elements we used only the D flip-flop because input is same, input is 1, output is also same. Output is with respect to input signal. So it is a D flip-flop. We can write it is a D flip-flop. D flip-flop. Okay, D flip-flop 1, D flip-flop 2. Okay, 0, 1, 2, 3. Right? D flip-flop, D flip-flop 3. Okay, flip-flop means store. Okay, store 1 bit data. Store 1 bit data, right? Store 1 bit data. Okay, store 1 bit data till next clock pulse applied. Till next clock pulse applied. Next clock pulse applied. Next clock pulse applied, the data is remains same till next clock pulse applied. So this is a flip-flop. It stores data, 1 bit data storage. So first clock pulse is applied, the data will be, data is 1, it is shifted to the shift right, the right side it is. We can also see the left shift. It is a right shift operation, right? You can see this one. And next clock pulse is applied, data, it is shifting from, let us take the 1 bit data. Okay, let us take here, it is, you can see data is equal to 0, right? The data will be shifting. Okay, data will be shifting, right? Only one data it is processing one. You can see this one. What happens here? Data 0. So what happens? 0 over here, 0 processed over here. The 1 will be shift right and 0, 0, right? Now, the next clock pulse is high, data is equal to 0, it will be shifted over here and the 1 will be shifted this side. Okay, you can see this one. The data will be shift right, 0. And the last one, high clock pulse, data is 0, 0 over here, 0 over here, 0 over here. Again, this data will be shifting right. So it is a shift right data. Okay, so it is a shift right data, shift right data, right? Shift right data. So D flip-flop data input is applied. It is a process through the flip-flop. So same input. If you are applying 0, 0 output. Next clock pulse, then it will be shifted to this one. Okay, next clock pulse it will shift 1, 2, 3, 4. 4 clock pulses, the data will be come out. So write operation in this write operation, write into the register. So write operation is write into the register. Write operation, write operation, write operation is data through registers, data into registers, data into registers. Okay, data into flip-flop registers, data into registers, right? For read operation, for read operation, what is a read operation? What is a read operation? So data from, read operation is data from registers, data from registers. So it will be come out from the registers, data from registers. Data from registers is a read operation, right? So this is what happening. So right into the data will be processed into these flip-flops. It will be moving. Shift right. 1 clock pulse, second clock pulse, third clock pulse, right? So it is how many? 1, 2, 3, 4. After 4 clock pulse, the data will be come out serially. The data will be come out serially. You see, this is the data, one output is come out. Okay, so one is applying. So initially it will be shifted. After first clock pulse, data come over here. Second clock pulse, third clock pulse, and fourth clock pulse. So this is our serial output data. Okay, serial output data, serial output data, right? So this is a serial output data which hold and process shifting. Okay, it which store and shifting. So it is nothing but serial access memories. Serially it will be shift right or shift left, right? This will be happened. So write operation, it is through the registers. Okay, read operation from the registers, it is from the register. This is output of 1 after 4 clock pulse applied, right? Let us see the second one is serial in. What is serial in? Parallel out. Serial in parallel out. Okay, serial in parallel out data. Okay, serial in parallel out data. So let me go and explain this one. Let me draw the circuit diagram by using flip-flops. Right? So it is serially we are applying, taking parallel output data. Serial input, parallel output. Right? Here we are taking the 4 input data. Here we are taking the 4 input data, 4 flip-flops. So output also 4, right? It is a flip-flops. The connections, you can see this one. We take output over here, parallel output data, serial in, parallel out. So let me take data input. So this is data input we are applying. So flip-flop D naught, output is Q naught, D1, Q1, D2, Q2, D3 and Q3 ma. So output over here parallel Q naught. So from here we can take output Q naught, Q1, okay, Q2, right. This is Q2 over here and this is Q3, right. Parallel output data. So parallel output data from here to here. So this is parallel output data. Parallel output data. Parallel output data. When data is applied serially, so every time, every clock pulse, we can take the parallel output data. So every clock pulse, we are taking the output data, right? So let us see this one. A clock pulse is applying, right? A clock pulse is applying. Every clock pulse we are applying, the data will be taken. Every clock pulse is applying, the data will be taken, right? Data will be taken. So this is serial in, parallel out. So every clock pulse, every clock pulse, every clock pulse, parallel output data taken. Parallel data output. Parallel data output. So every clock pulse we are applying, we are taken the parallel output data. So parallel data output, right? So this is serial in, parallel output data, right? Now the another one is, what is another one? Third one is parallel in, serial out. Parallel in, serial out. So let us say this one, parallel in, serial out. You can take the connections over here. See carefully. So parallel in, serial out and parallel in, parallel out, somewhat the circuit diagram is somewhat difficult. So you just practice, then it will be easy for you. Right? 1-2 times you can practice. It will be easy. You can take. Right? So parallel input data. So when we are applying parallel over here, right? So let me draw this line from this path, okay, and another path over here, okay. So let's see this one. So we'll apply inverter over here, okay, inverter over here, right. This is a path from here to here, right. From here we can take AND gate, right. This is one AND gate over here. Let me draw directly so that. So this is parallel output data and one path from here and another one. So from here to again one AND gate, right. Here also one AND gate. Let me the this portion, and from this is a parallel output data, parallel input data from here. So this is two outputs are given to one OR gate, okay, one OR gate. So this is again one AND gate, right. This is one AND gate. So OR gate, from here we can take OR gate, okay. Let me draw this one. This is one AND gate. Here also one AND gate. So from here to here, right? And from parallel output, parallel input, and from here, okay. From this, you can take one OR gate. Both are connected to one OR gate, okay, as a input to the next state, okay. So this is A, parallel input B, and C, this is D, right? Then output is serial output data, serial output, serial output. So let us take D naught, D1, D2, D2. Wait a second. So this is D naught, Q naught, D1, Q1, D2, Q2, D3, Q3 Okay. So and this AND gate. Let us take this A1, A1, A2, right? A3. Okay. This is A4. This is A4, A5, and A6. Right? This is a parallel input data. So parallel input data. Parallel input data. Parallel input data. This is parallel input data. Right? Serial output data. So every time we are applying the clock pulse. Right? Let me see the clock pulse over here. You can see this one. The clock pulse, every clock pulse is applied, the data will be processed. Every clock pulse is applied, data will be processed. Okay, so this is first one is it is a shift load bar. Okay, shift load bar. Shift load bar we are giving. Okay, shift load bar we are applying. When shift load bar is equal to low, shift load bar is equal to low, then complement is 1, complement is 1. What happens? What happens? This A4, A5, A4, A5 and A6 are enabled, right? A6 are enabled, so then it allows the, this is 1, right? This will be 1, this will be 1, and this will be 1. What happens? It allows the parallel data. Okay, one indicate one terminal is on, one terminal is on, then it takes the ABCD parallel input data, right? The next one when it will be high, when it will be high, then this one will be high, this will be 1, this will be 1. Okay, and sorry, this will be 1, and this will be 1, this will be 1. Then the data previously, when parallel data is taken, then the q naught, from the q naught it will be applied. So when it will be high, then data will be processed through the shifting to the next level. So first parallel data is taken when shift load bar is equal to low. Okay, parallel data is taken. So this AND gates will be on, A4, A5, A6 will be on. The second A1, A2, A3 and shifting to this next level D1, D2, D3. Then shift load bar is equal to high. Right? Let me write here. Let me write this point. So when the shift load bar, when shift load bar is low, shift load bar is low, what happens? What happens? A4, A5, A6, A4, A5, A6 enable, enable allows the, allows parallel input data, parallel input data, allows parallel input data. Okay, now when, then the AND gates of A4, A5, A6 are enabled. When shift to load bar, when shift to load bar is high, when shift to load bar is high, then what happens? Shift to load bar is high, what happens? So A1, A2, A3 are enabled. A1, A2, A3, A3 gates, A3 gates, A3 gates enable, A3 gates enable. Then data shifting, data shifting, data shifting right, data shifting right. Okay, data shifting right. So data shifting right, D1 to D1, D0, D1, D2 and D3, right? D0, D1, D2 and D3. So then after four clock pulses, after four clock pulses, after four clock pulses, right? What happens? Data output taken. So serial data output taken, right? Serial data output. This is what happened. This is what happened in this parallel in serial out. Okay, this is what happens parallel in serial out. The last one, fourth one is parallel in parallel out. Now the last one is parallel in parallel out. Let us see this one. Okay, let us see this one. Parallel in parallel out. So we have four again flip-flops. Four flip-flops are here. Okay, we can take inputs and these are the outputs, right? Inputs and outputs, right? Inputs and outputs. Okay, so let me take this one. Okay, now from here to here, one NOT gate we are applying, one NOT gate we are applying. Okay, so here this is a AND gate. Okay, and here also let me dot directly. So this is one AND gate. Okay, again this is one AND gate. Okay, this is one AND gate again. This is one AND gate, right? Okay, so from here to here we are taken. Okay, now it is a read and write complement. So we are taken D0, Q0, D1, Q1, D2 and Q2, D3 and Q3. So here outputs are here. Okay, so outputs are right. Taken output indicates parallel outputs, right? The parallel outputs, parallel output. This is a parallel output. Parallel output, okay? Parallel output. You see this one, parallel output. So parallel output Q0, Q1, Q2 and Q3 parallel outputs, right? Read write bar. So read write bar is equal to low. Okay, whenever it will be low, the complement is 1. Okay, the complement is 1. So what happens? So this will be on. This will be 1. Okay, this will be 1. This will be 1. Right? This will be 1. The parallel data, which allows the parallel data. Right? Which allows the parallel data. Right? Let me take this one. This path is right. This is a parallel data is taken. Okay. The parallel input data is taken, right? Parallel input data is taken. Let me take this path, right? The parallel input data is taken. D0, let me take this D0, D1, D2 and D3, and outputs are parallel output data. Outputs are Q0, Q1, Q2 and Q3. Okay, when read write bar is equal to low, it will be 1. So it will be 1. So one AND gate will be one path is 1. One path is 1. Okay, one path is 1. Now, which allows the data. Okay, let me take this one. Right. Okay, 1 second, this one. Actually, this path is from, you can directly connect to this D2 and D3 from AND gate output, right? So from AND gate output, we can take here, right? One path is here. Okay, you can take this one. This path will be taken over here, right? So one path is complement, it will be 1. Okay, then the data will be taken. So this will be 1 and data will be parallel data will be taken. So this will be 1, this will be 1, data will be taken. Parallel data will be taken, right? Every time you are applying a clock pulse. Every time you are applying a clock pulse, right? Every time you are applying a clock pulse. So this is what happened. So this is a clock pulse, this is a clock pulse, this is a clock pulse. So when the clock pulse is applied, when the clock pulse is applied, so read write operation is equal to low, then it is write into the, it will write into this flip flops, right into the flip flops. This will be 1 and allows the parallel data when it will be high. When it will be high, okay, when it will be high, what happens? So this will be 1 and data will be taken output. Data will be taken out. So this is parallel output data, right? Let me finish this one. So when read write complement is low, read write complement is low, so parallel data taken. Okay, parallel data is taken. Parallel parallel data input. Okay, so when read write complement is high, read write complement is high, so parallel, okay, parallel data output, parallel data output taken. Okay, parallel data output is taken, right? Parallel data output is taken. So this is what happened in this serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. Okay, so output of this one, right? When read write complement is low, the parallel data is taken, the parallel data is taken. Okay, when read write will be high, then what happens? The data output will be taken. So data is applied D naught, Q naught, D1, Q1, D2, Q2, D3 and Q3, right? This is what happened in this serial access memories. Thank you. Please subscribe our channel, like and inform to your friends. Thank you.